we continue our discussion. Previously, we have discussed on the steps to determine the buckling design resistance to bending moment. So the first step is to determine the length of unrestrained segment. Step number two, determine the modified factor C1 based on bending moment diagram shape. So for uniform bending moment, the value of C1 is equal to 1.0. Then when there's a point load applied on the simply supported beam, the shape of bending moment is triangle shape. So the value of C1 is equal to 1.35. So when the bending moment on a point load is applied on a simply supported beam, and there is a secondary beam introduced here at the point where the bending moment where the point load is applied. So normally this P. So then the bending moment diagram will be in this shape. Zero at the end support, and then this one's M1 and M2. So for the triangle shape here, C1 is equal to 1.77. Same goes to this one. C1 is equal to 1.77. For the trapezium shape, at the interior span, M1 and M2. So the C1 is determined by the ratio of the bending moment, M1 over M2. So it will give you the value of C1. There are numbers of proposed empirical expression to determine the value of C1 based on the ratio of bending moment. Step number 3, calculate the elastic critical buckling strength, MCR. This is the value of the expression. Then C1 introduced here. The value of C1. Precision first. Auto B and C1. Then step number 4 is calculate the non-dimension slenderness. Lambda LT bar. And the lambda LT bar is equal to square root of Fy times plastic modulus about y axis over the MCR that we calculated in the previous step. Then we determine number 5. Calculate the HOB to determine the value of imperfection. After the HOB to determine the buckling curve. Then we use the information to determine the imperfection factor. So for the buckling curve, we have to refer to table 6.5, Euro code 3 part 11. So for the roll section, the limit, there are two limits for the HOB. HOB less than equal to, and then HOB bigger than 2. And then the buckling curve, for the first limit is B, and then for the second limit is buckling curve C. And step number 6, determine the imperfection factor. Alpha LT. Refer to table 6.3. Euro code 3 part 11. Then step number 7, calculate the buckling parameter. Buckling parameter VLT. VLT. You can find the expression of the PLT in equation 6.56. PLT is equal to 0.5 times 1 plus alpha LT times lambda LT bar minus 0.2 plus lambda LT bar squared. Okay. And then number 8, we calculate the imperfection factor. Sorry, the reduction factor. Reduction factor CLT. So the CLT is equal to 1 over PLT plus square root PLT squared minus lambda bar square LT, and then the value of CLT should less than equal to 1.0. This is the limit, so should be a reduction. And then step number 9, if the C1 is not equal to 0, so then the enhancement factor enhancement factor F need to be calculated. It's required. So F is equal to 1 minus 0.5 multiplied by 1 minus 1 over square root C1 times 1 minus 2 times lambda LT bar minus 0.8 squared. Then step number 10, calculate the modified modified uh, modified reduction factor CLT modified. There is the CLT mode modified reduction factor is equal to CLT over F, and should not exceed 1.0, less than 1.0. Number 11, calculate the MBRD. CLT modified reduction factor times Fy plus tick modulus about Y over gamma M1. That's all the long step of determining the buckling design resistance to bending moment. So it is started by determining the L, then determine the modified factor C1 based on the BMD shape, then calculate the MCR. Number 4 is calculate the non-dimension slenderness, lambda LT, then calculate the HOB to determine the buckling curve, then refer to table 6.5 Euro 3 part 11. So for the roll section, there are two limits of the HOB less than equal to, and HOB more than 2. And step number 6 is to determine the imperfection factor alpha LT. Refer table 6.3 Euro 3 part 11, then followed by calculate the buckling parameter PLT. And then step number 8, calculate the reduction factor CLT. So if the value of C1 is equal to 0, so then we no need to calculate the modified reduction factor. But if the C1 is not equal to 0, the enhancement factor F is required. So the enhancement factor then followed by the step number 10 is calculate the modified reduction factor CLT mode. Then after that, we calculate the MBRD. That's all for this session. We will continue later.